Unit 3, Lesson 7, Converting from Standard and Factored Forms. So I'd like you to take it to do this for a moment is pause the video, and I'd like you to review expanding or converting from factored form to standard form by doing these 4 problems. So pause the video and come back to it in a minute. Okay, so hopefully you've had a chance to practice expanding these 4 questions. If you need to review, you could look at the previous video, lesson 6, to review how to do this. But if you did this correctly, the answers you would have had are as follows. For part A, the expanded form is, or the standard form is, y equals x squared plus 8x plus 15. For part B, you would get y equals x squared plus 5x minus 14. For part C, you would have y equals x squared minus 7x plus 6. And for part D, y equals x squared plus 8x. Now, if you have had these 4 correct, then fantastic. If not, you may have to do a little bit of review. Okay, now let's look at the following question. There's a pattern. There's a pattern between what you see in the factored form and what you see in the expanded or standard form. I want you to carefully look at what's happening here. If you look at what's the relationship between 3 and 5 and 8 and 15, 2 and 7, negative 2 and positive 7, and 5 and negative 14. Look for a pattern between negative 6 and negative 1, and negative 7 and 6, and 8 and 8. And this factored form here, you could think of this as y equals x minus 0 and x plus 8, because x minus 0 is just x, and they just write it as x. Okay. Now, you may notice that if I took the positive 3 and positive 5 in part A, if I add them together, I would get 8. And if I multiply them together, I would get 15. If I took negative 2 and positive 7 and I add them together, I get positive 5. If I multiply negative 2 and positive 7, I would get negative 14. And what about this one down here? Negative 6 and negative 1. When I add these 2 numbers together, I get negative 7. And if I multiply negative 6 and negative 1, 2 negatives make a positive, so I get a positive 6. And over here, 0 plus 8 gives me 8, and 0 times 8 is 0, which is why I have nothing afterwards. So there's a distinct pattern going on here. And let's write this pattern down. Let's say here the numbers in the brackets add, underline add, to the middle term or the middle number and that number is b in the expanded or standard form, and those same 2 numbers, and they multiply to the last number, and that last number is c in the standard form. And the standard form, again, is given by ax squared plus bx plus c. So there's a relationship between those 2 numbers in the factored form. If I add them, I get the b. If I multiply them, I get the c. And we're going to use that pattern that we see to help us go in the reverse direction, to convert from standard form back to factored form. Okay. Now, so how do we go from standard form to factored form? So let's start with our first example. I'm going to write a little note here just for ourselves, because we've discovered that pattern. What we're going to do is determine factors of C and choose the pair that add to B, and then put those numbers in brackets. Okay. So if the product of the two numbers has to be that C value 20, what I'm going to do is start out by writing out all the factors of 20, including the negative factors. So we have 1 and 20, so 1 times 20 gives me 20, negative 1 and negative 20, and 2 times 10 is 20, negative 2 times negative 10 is also 20, 4 times 5, and negative 4, and negative 5. Now, out of all these pairs of factors, you have to find out which pair will add up to the B term, 9. Which pair of numbers will add up to 9? Well, it turns out these two numbers add up to 9. 4 plus 5 add up to 9. So I'm going to circle these two numbers. These are the two numbers that are going to make up the factors in our factored form. So the factored form can be written as x, and if it's a positive 4, you write plus 4. Close the bracket, make your next bracket x plus 5, because the other number is positive 5. And there's our factored form. And you can check by expanding it again to see if you get the standard form. Okay. Same thing. So what we just did was we took the C values, we determined the factors of C. So here are all the factors of C, and we choose the pair that add to B, put those numbers in brackets. And that's what we did here. Okay. Let's do that one more time with part B. Just got to get my screen to load. Yep, there we go. So here, standard form. You start by writing out all the factors of negative 28. It's minus 28, so you have to say negative 28. Those factors are minus 1 and positive 28, positive 1 and negative 28, negative 2 and positive 14, positive 2 and negative 14, negative 4 and 7, and positive 4 and negative 7. And then you check which pairs of numbers will add up to give you the B term, the number B, negative 3. And so it turns out if I add 4 and negative 7, I will get negative 3. No other combination does this. Negative 4 and positive 7 give you positive 3, but I want negative 3 because of the minus sign. Okay? And so what happens here? Well, I can just write the factored form by saying y equals x plus 4 and x minus 7. Okay. Now, let me show you one more thing. What's really happening behind this math? If I took y equals x squared minus 3x minus 28, okay, and what we're really doing mathematically is we're taking this middle term minus 3x and we're splitting it up. So if I could rewrite the question as y equals x squared, and minus 3x could be written as plus 4x and minus 7x minus 28. Okay, and what we're doing next is we're doing some common factoring, right? So you common factor the first two terms. What's the common factor? It's going to be x. It's going to be x. So I factor out an x. Y equals x, and I would have x plus 4, right? Because x times x is x squared, and then x times 4 is 4x. And if I common factor the next two terms, well, the common factor between negative 7 and negative 28 is negative 7. So I can factor out a negative 7 by putting a minus 7. And then negative 7x divided by negative 7 is x, and 28 divided by 7 is 4. Two negatives make a positive, right? And then you'd notice you have a common expression, so the common factor can be an expression in brackets. If I factor that out, I would have y equals x plus 4 and x minus 7. Now, this is what's happening. This is what you need to understand when we do more complicated factoring. But for now, the shortcut is okay. Okay, let's move on to another example. Factored form. Start from the standard form. What are all the factors of 15? Well, you have 1 and 15, negative 1 and negative 15, 3 and 5, and negative 3 and negative 5. Which pair of numbers add up to give me negative 8? Well, it turns out negative 3 and negative 5 are those pairs of numbers. So you write out the factored form y equals x minus 3 times x minus 5. Okay, let's try another pair. Standard form. Factors of negative 9. Well, you have 1 and negative 9, or negative 1 and positive 9. Which one gives you negative 8 when I add them? 1 and negative 9. So the factored form is y equals x plus 1 and x minus 9. Standard form, x squared plus 3x minus 18. Factors of negative 18 are, so at some point you're going to realize, okay, you can do this in your head. You go, okay, what are two numbers that add up to positive 3 and multiply to negative 18? If you do this with enough practice, you'll get more comfortable and much more faster in doing it. And so the factors here are going to be negative 6 and positive 3. But if you still can't figure it out, you can write out the list of all the factors like you did before, and you can figure it out that way. Start from the multiplication and work your way to the addition. So negative 6 and 3 is my answer. So my factored form will be x minus 6 and x plus 3. Oh, I think I made a mistake there. Positive 6 and minus 3. Positive 6, negative 3. Okay. And so again, if you make a mistake like that and you're not sure, you can always expand your result to find out. So you have x times x, which is x squared. X times minus 3 is minus 3x. 6x and minus 18. And so you have y equals x squared plus 3x minus 18. And then part F, factored form from the standard form. Now, you might encounter a situation where if I look at the factors of negative 5, well, 1 and negative 5, or negative 1 and positive 5, but none of these combinations add up to positive 3. In this case, it's not possible to find a factored form. So we're going to say here, therefore, no factored form. And that's possible, right? Because if you have a parabola, remember, a factored form gives us the x-intercepts, the zeros. But if you have a parabola like this, there are no x-intercepts. There are no x. The graph does not cross the x-axis. So here's a graph of a parabola that will not have a factored form. So it's possible that they exist. Okay, so let's summarize some of the things that we just did here in this lesson. So how do we determine factoring trinomials? In this case, we're going to call this simple trinomials. So 3 steps. First, determine factors of C. Step 2, choose a pair of factors that add up to B. And then step 3, put them in brackets like this. So x, and then your number, and then x, and then your number, and don't forget the signs. Okay, and that's it. And that ends this video.